In section 8.3, we're going to extend our idea of hybrid orbitals to allow for multiple bonding, and then we're going to extend that concept to the idea of resonance that we learned about before. A little refresher here. Single bonds are formed by sigma bonds, and multiple bonds are formed by pi bonds. Pi bonds are not created by hybrid orbitals. Hybrid orbitals only form sigma bonds. Multiple bonding occurs from the unhybridized orbitals that are left over. To determine the hybridization in molecules with multi-bonds, recall that a double or triple bond is each one region of electron density. So if we look at our molecular orbital diagram, prior to this, we had just enough electrons to fill all of our hybrid orbitals. But what happens when there's enough electrons for an electron to go into one of these unhybridized orbitals? If we look at the case of ethylene, we can see that there are these p orbitals that are still present here, unhybridized. If an electron goes in there, then they're going to form this side-to-side interaction, producing a double bond. If we think of the case of benzene, each one of these carbons is just as happy to form that side-to-side interaction with either one of the carbons next to it. It would just as much prefer to be here as it would prefer to be here, and in fact it's going to go back and forth, forming those side-to-side interactions with its neighbor really fast, back and forth, to make a resonance hybrid. Triple bonds can be formed when there are two unhybridized orbitals, each with an electron in it. In this case, we're forming acetylene through two side-to-side interactions with those p orbitals.